Okay, so there were a couple questions about the quiz. So instead, I write that. I thought it could be better to explain how to solve those problems. Okay, maybe your problem has different numbers, but you're gonna have very similar problems here, right? So this problem is what is it? It's about arithmetic sequence. So the sum of two consecutive terms in the arithmetic sequence 2, 5, 8, 11 dot 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 is 301. Find these two terms. So here there are a lot of things going on. The sum of means you add those two together and got the answer, right? Two consecutive terms. So like in integers, like 1 and 2 are two consecutive terms. Negative 3 and negative 2 are two consecutive terms. So 2 and 5 are two consecutive terms. 5 and 8 are also two consecutive terms. And so on in this arithmetic sequence. What is arithmetic sequence? You are adding same number continuously. So in this sequence, you can see, oh, I add 3 to get the second term from first term. Do the same rule. You add 3 to get 8 from the second term. To get the fourth term, you add 3 to the third term. So we know that arithmetic sequence here, we can generalize this using the rule that we have talked about. So we know this arithmetic sequence, nth term is the first term plus n minus 1 times d. D is the change. So we know that it's changing as 3, right? We are adding 3 in the previous term to get the next term. So d is 3, and the first term is 2. The first term is 2. So 2 plus n minus 1 times 3. You can keep it like this, or if you want to simplify this, you can also simplify that. So n minus 1 whole thing times 3, so you're gonna distribute 3 to n and negative 1. 3 times n is 3n. 3 times negative 1 is negative 3. So you can switch these two around using commutative property in addition. So you get 2 minus 3 plus 3n is equal to negative 1 plus 3n. You can keep it like that, or that's the same as 3n minus 1. This looks more familiar to us, right? We usually put the variable term, then constant. So if we use either this or that or that or that or that, it's all same thing. They're all equal, so it doesn't matter. But we know the nth term, so somewhere here you have nth term, and you're gonna have one less than that, should be a to the n minus nth term, excuse me, and n plus 1th term, right? So if nth term is 3n minus 1, the next term, we can put that as n plus 1th term. That should be 3 times n plus 1 minus 1. If you simplify that, you can distribute 3 to n and 1. So you get 3n plus 3 times 1, 3, and you have minus 1. So the next term after 3n minus 1, it should be 3n plus 2. Or you can just use this one. And we know the next term is 3 more to this. So add this by 3, then you get 3n plus 2. So these two are the terms that are consecutive. When you're adding them, you get 301, because it says the sum of two consecutive terms in this sequence is 301. So when you're adding these two terms, you're gonna get 301. And you're gonna find what n is, which means nth term. We're gonna find what in what order that 3n minus 1 is. So when you're adding these two consecutive number, you can find n. That means it's a to the what the term, okay? Plus 3n plus 2. So this is one term and this is the next term. That is these two are the consecutive ones. So when you are adding them together, you can use commutative property. So we can do 3n minus 1, plus 3n. I'm moving this here and moving that to the other way around. Plus 2. So you have a 6n plus 1. Now it's algebra. So you can subtract 1 on both sides and you get 300 on the left hand side, right? And right hand side you have 6n. How can we solve for n? You can divide both by 6. So n is equal to 50. So my first number is the 50th term, and the value there on the 50th should be 3 times 50 minus 1, because my n is 50. 3 times 50 minus 1 is 150 minus 1, 149. That is my first consecutive term, 149. And the second consecutive term is 3 more than that. So you can add that by 3, which is 152. Or you can plug in 50 here, the second term, and you get still 152. 3 times 50 is 150, plus 2 is 152. So you can solve this problem. The next problem I have is this. The amount of money in cents, in cents in a jar containing some nickels and D dimes, some quarters. If there are times as many nickels, something is missing. Okay, hold on. I think it was saying 6 times. There are 6 times as many nickels as dimes and twice as many quarters as nickels. So by looking at this, we can see the relationship between number of changes, right? So by looking at this, we can say some nickels, so we can say there are n many nickels, and there are d many dimes, and there are q many quarters. So n, d, q are the number of changes respectively. Okay, number of changes, number of nickels, number of dimes, and number of quarters. And we also have more information here. There are 6 times as many nickels as dimes. By looking at this, we can put an expression there. So let's put that as 1. We can have a relationship between the nickels, number of nickels, and number of dimes. It says 6 times as many nickels as dimes. Which one has more? Nickels is more, right? You have more nickels by 6 times of dimes. So let me rewrite that with lowercase, because I put the lowercase there. So I can put n is equal to 60, right? And the second part here, it says n twice as many quarters as nickels. Which one is more? You have more quarters, right? So the quarters is twice as nickels. Twice as many quarters as nickels. So we can set up these two relationship here. So the total number of the changes is like this. Number of quarters, and number of dimes, and number of nickels. The total is Q is 2n, and D is 60, and N is N, right? But we want to have only one variable. We also know that N is 60, so can we change all of these to the D term instead of N term, and mix of N and D term? Yes, we can, right? So we can substitute N with 60. So 2 times n is 2 times 60. And this is, hold on, d is still d. So d, and n is 60. So that's what we got. And what do we have? 12, 13 plus 60 is 19d. So the number of changes here, we know it's 19d. However, this is not what we want. It's asking the expression for the amount of money in the jar is 300. This is the question. How many cents? How many cents is the question. If you're writing this in terms of d, you're counting how many dimes there are. So this is not what it's asking us, right? Instead, we can think about in cents. So we know in quarter we have 25 cents, right? And in nickel we have 5 cents. In dime we have 10 cents. So think about that. Okay, so we have some coins, but each coin has 25 cents. So if you multiply that by number of coins, that's how much you have in cents. And for nickels, each nickel has a value of 5 cents in number of nickels. So when you multiply them together, that's how much the amount of cents in nickels. And in the dime, each dime costs 10 cents, right? And that's the number of dimes. So that's how much you have, right? So think about this. 25 times Q. How many quarters are there? 2 and many. But we can change this to how many dimes. As you can see in this previous question, we could change everything in terms of D. So here we can change it. We know that we can change this to D term as well. So instead of N, you can put 60, which is 12D, right? So instead of Q, we can put, that's 25 cents times 12D, and 5N. 5 times N is 60, and you have 10D. Now we have everything in the value of cents, because this one shows in cents, right? Okay, what's 25 times 12? I need a calculator. 25 12 is 300 D, and you have 30D. 5 times 60, 30D, and you have 10D. So total 300 plus 30 plus 10, you get 340D in cents, right? So the answer is 340D. Okay, these two problems are the questions some of you have asked. If you have any further question, please don't hesitate to ask me. Okay, hope this helped. Have a good day, guys.